Good morning. So now I'm come back right now. So today we need to talk about section 4.3. So section 4.3 are all about right triangle trigonometry. So 4.1 we learned radian, like degree and radian angle. We did. Also we have a quiz. So 4.2 we do the unit circle. So we use the unit circle to define six trig function. Six trig function like a sine, cosine, tangent, cotangent, secant, cosecant. Do you remember? If you practice, I believe you can remember all these six trig function. So today we need to use the right triangle to define six trig function. So now right triangle, you should know what is a right triangle. So right triangle is one angle is a right angle, right? So like this, I already drew a right triangle here. If one angle is 90 degrees, we call right angle, right? If the one angle is 90 degrees, we call this triangle is right triangle. So today, I need to use this right triangle to define this six trig function. So now, first, we already learned what is sine. So before we talk about sine, cosine, the definition, so we need to define some side, the name of the side. If I have an angle theta here, so we call this side the opposite of this angle theta. We call this is opposite side. Also, we use the OPP to represent opposite side. And then we use, if the opposite of the right angle, we always call this the longest side is hypotenuse. Okay, this we call hypotenuse. And also the other side is near the angle theta. We call this is adjacent side. Okay, we use ADJ to represent the adjacent side. Now we need to define this six trig function. First, what is sine theta? As you see, theta is here. So sine theta is opposite OPP over hypotenuse. Okay? So that's the definition. It's a little bit different from the unit circle. So unit circle is to give you the x and y coordinates, right? So sine is equal y, correct? The y coordinates. But for the right triangle, because sine is the opposite side over the hypotenuse. As you know, sine, cosine, tangent, always just a ratio, a rate. So also it's a fraction, as you know. So we define sine is the opposite over hypotenuse, okay? So now we call, what is cosine? Cosine is the adjacent side, A, B, J, over hypotenuse, okay? That is cosine. So what is tangent? Tangent is opposite OPP over adjacent. Okay? So after you just memorize these three trig functions, and then you can find the other three, right? Before we talk the other three, we also use the American way to memorize these three. So also we have a lot of video online, or also if you learned the trick before in America, they use this kind of strategy to memorize all these three functions. So sine, you just can use sine is, we use cosine is toa. Okay, so it means zakotoa. So what that means? It means they use this strategy to memorize these three trig functions. So is sine, right? Sine, S is sine, is opposite O. So they always use the first letter to memorize this trig function. So SOH is sine. Sine is opposite over hypotenuse. Cosine C is adjacent A over hypotenuse. AH, right? So tangent is opposite O over adjacent. Okay, that is so SOHCAHTOA. They use this name to memorize all these three. Also, you can use this to memorize. Okay? So now, after we define the sine, cosine, and tangent, what about cosecant? Right? Do you remember what's cosecant? And also based on the unit circle, cosecant theta is the flip 1 over sine, right? If you can remember. Also, it's the same thing for here, for the right triangle. So if cosecant is 1 over sine theta, so that means is hypotenuse over opposite. Okay? I'm not sure you can see this on this side. Maybe I can rewrite on here. Cosecant is 1 over sine, so that means is hypotenuse over opposite. Okay? So if you know the sine, cosine, tangent, you already know the other three. See, because cosecant is the reciprocal of sine, and also secant is the reciprocal of cosine. Okay? So that means it's a hypotenuse over adjacent. And how about cotangent? Cotangent is 1 over tan. So that means it's adjacent over opposite. Okay? That's the definition of all these 6 trigonometry functions. Now, I want to use an example how we can use the right triangle to evaluate trig function. So now, if I have a right triangle here, okay, and I said this is the theta here. If I have 3 on this side, 4 is here. So I just give you 2 sides. Okay, 2 sides, and then I'm looking for sine, theta, cosine theta, and tangent theta. Okay. This is an example. How we can use a right triangle to evaluate a trig function. Based on the definition, if you use the right triangle to find some value of the trig function, you have to know all these 3 sides, because sine theta, as you know, sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent is opposite over adjacent. That means you have to know all these 3 sides. So now for this triangle, which side is opposite? Which side is adjacent? And also which side is hypotenuse? Now I want to use this as example. So as you know, the theta is here. So which side is opposite? It should be the opposite of the angle. So it means this side is opposite side, OPP here. And also the hypotenuse, always the longest side, is the opposite of the right angle here. So they mean this is the hypotenuse. And the other side is the side near the angle theta, so we call this side adjacent side. So we already know adjacent and opposite because that's a given information. Adjacent is 3, opposite is 4. The hypotenuse, that means we don't know what is the hypotenuse. So because this is right triangle, that means you can use the Pythagorean theorem. So do you remember what is a Pythagorean? So Pythagorean theorem is if this is right triangle, this A, this B, this C, that means you have to know A squared plus B squared is C squared, right? That is a hypotenuse theorem, Pythagorean theorem. So now we know A is 3 because we're looking for C. We don't know the hypotenuse. B is 4. So what is C? So now 3 is square is 9 plus 4 square is 16 and equal C squared. Okay. Now C squared, that means 9 plus 16 is 25 is C squared. That means what is C? So C is 5, right? So that means the missing side hypotenuse is, the value is 5. So now based on this information, you already know 3 is adjacent, 4 is opposite, hypotenuse is 5. Now, you already know all these 3 sides. So what is the value of sine? So based on this definition, sine is opposite is 4 over the hypotenuse is 5. So that means the value of sine of this angle theta is 4 over 5. Okay? And cosine is adjacent over hypotenuse. Adjacent is 3. The hypotenuse is 5. So that means the value of cosine is 3 over 5. Okay? So now, what is tangent? Tangent is opposite over adjacent. So the opposite is 4, I'm sorry, 4. So adjacent is 3. So that means tangent is 4 over 3. So we have 1, 2, and 3. Okay? 3 answers for sine, cosine, tangent. Easy, right? So maybe use the right triangle to define 6 triangle is easier than the unit circle. But what's the difference? The difference is use the right triangle, the angle always is acute angle. That means you just use the right triangle to define the acute angles trigonometry. If the angle bigger than 90 degrees, you cannot use the right triangle. Okay? Now I'll give you one more example, then we're done for today. And also you have used this example to finish your homework. So now I'll give you another example. I want to, how about you this side? And also remember, use the Sakatoa to memorize the sine, cosine, tangent. So now if I give another example, if I have a right triangle here, right? If this is the theta, I said this time the theta is here, okay? And if I said this is 5, if this is 13, okay? I just give you 2 sides, always have one missing side. And the angle is here. And I'm also looking for sine theta, cosine theta, and tangent theta, okay? So now, how we can solve this question? So, we need to find out the first step. Find the missing side. So which side is missing? So now we call theta is here. That means which side is opposite? The opposite is 5, right? This is opposite side. Okay? And also the hypotenuse side is the opposite of the right angle. That means this side always is the longest side is hypotenuse. So that means the other side, this side is close to the angle, this adjacent. So adjacent is missing. So now we need to find out the adjacent side. As you know, also we can use the Pythagorean theorem. So Pythagorean theorem is a squared plus b squared is c squared. C squared is, okay. So c squared is the hypotenuse. So that means we're looking for the b here. If A is 5, plus b squared is c squared is 13 squared. Because why c is 13? Because c is the hypotenuse. C is the longest side. So now, how we can find out b? So that means this 25 plus b squared is 13 squared is 169. So that means b squared is 169 minus 25 minus 25, it should be 144, right? So 144, that means b square root both sides, you get b is 12. So that means adjacent is 12 here. Okay? So now we need to find out what is sine. So based on the definition, sine is opposite over hypotenuse. So that means opposite is 5 over hypotenuse is 13. So that means sine theta is 5 over 13. Okay? So cosine theta is 5. Cosine is adjacent over hypotenuse. So that means adjacent is 12. Hypotenuse is 13. So that means cosine is 12 over 13. Okay? So now tangent is opposite over adjacent. So opposite is 5. Adjacent is 12. So that means tangent is 5 over 12. Easy, right? So if I give you this question like as example, how to find out sine, cosine, tangent? The first step, you need to find out the missing side. Okay? If I give you, always just give you two sides. So find out the missing sides, first step. Second step, you need to define which side is opposite, which side is adjacent. Remember, hypotenuse always is, you never change the hypotenuse. The hypotenuse always is the longest side of the right triangle. So adjacent and opposite, they based on the angle. If angle here, the theta here, so the opposite side is this side, right? If the angle is here, so the opposite is this side. So the other side is adjacent. So now, after you find out this, all these three sides, and then use the definition, sine, cosine, tangent, to find out the value of the trig function. So if you you cannot remember, also you can use SOHCAHTOA SOH as OH, sine is opposite over hypotenuse. Cosine, cosine, adjacent over hypotenuse. TOA, T tangent, is opposite over adjacent. SOHCAHTOA. So, now we're done for today. So now I will post the homework later. So all about this example. I give you maybe 5 questions, okay? So have a good day.